Hello my dear students, welcome back to our channel. We were discussing statistics. In the last video, we have seen how to find mean deviation about mean and a median for discrete frequency distribution. And today we can see mean deviation about mean for continuous frequency distribution. Before going to the video, please do subscribe to our channel. Okay, we can go to the video. Continuous frequency distribution. In continuous frequency distribution, data are classified into different class intervals with the respective frequencies. For example, we can say marks obtained by students in a class. In continuous frequency distribution, we can say marks 0 to 10. Some 5 students, 10 to 20. Some 10 students, 20 to 30. Some 8 students, 30 to 40. 5 students, like that. This is continuous frequency distribution. Here marks are classified into a class interval 0 to 10, 10 to 20, like that. One more thing, there is no gap between this interval. So today we will see how to find mean deviation about mean for this continuous frequency distribution. We can see. How will we find mean for this continuous frequency distribution? Here no xi we have. So we are taking xi as the midpoint of each class. For example, here we can say x1 is equal to 5. Here we can write xi. Here 5, here 15, here 25, here 35, like that. Then we have xi. Next, to find mean, we can proceed as in the case of discrete frequency distribution. We know the formula for mean. X bar is equal to sigma xi fi by n. I from 1 to n. Here xi is the midpoint of each class. Fi is the frequency that we know, and n is equal to sigma fi. So if we get mean, then what is mean deviation about mean? Mean deviation about mean, we can just proceed as in the case of discrete frequency distribution. That is 1 by n into sigma fi into mod xi minus x bar. I from 1 to n. So we can see one example, then it will be more clear to you. Here the just difference is xi we are taking the midpoint of each class interval. Example, find the mean deviation about the mean for the following data. Here the data is given, continuous frequency distribution. So what is the formula for mean deviation about mean? We can write the formula. Mean deviation about mean is equal to 1 by n into sigma fi into mod xi minus x bar. I from 1 to n. So to find mean deviation about mean, first we need mean. So x bar is equal to, we know the formula, sigma xi into fi by n, or 1 by n into sigma xi into fi. We know xi is the midpoint of each class. So we can make the table. So first we can write the marks that is given here. From this we can write the xi, that is the midpoint, xi or midpoint. Fi, frequency is given here, number of students. Then we need to find a mean xi into fi, sigma xi into fi. So we can write xi into fi, next column. After getting mean, we can find mod xi minus x bar. Then fi into mod xi minus x bar. So this much column enough. Just as like in the case of discrete frequency distribution, here the only difference is we are taking xi as the midpoint. So we can write marks given 10 to 20, 20 to 30. So midpoint here 10 to 20, 15, here 25, 35, 45, 55, 65 and 75. Frequency given 2, 3, 8, 14, 8, 3, 2. Next xi into fi, that is this column into this column, that is 15 into 2, 30, 25 into 3, 75, 35 into 8, 280, use calculator, 45 into 14, 630, Next 440, 195 and 150. Next we need sigma xi into fi. That is sum of the values in this column 30 plus 75 plus 280 plus etc. plus 150. That is we will get 1800. What is capital N here? That is sigma fi. 2 plus 3 plus 8 plus 14 plus 8 plus 3 plus 2. That is capital N is equal to 40. So we have sigma xi, fi and n. Next we can find mean. X bar is equal to sigma xi, fi, that is 1800 divided by 40, which is equal to 45. So we have get mean 45. Next we can find mod xi minus x bar. X bar is 45. So mod xi minus x bar, modulus of this column minus 45. That is modulus of 15 minus 45, 30. 25 minus 45, 20. Like that, write all the values. Next 10, 0, 10, 20, 30. Next fi into mod xi minus x bar, that is this column into this column fi, that is 2 into 30, 60, 3 into 20, 60, 8 into 10, 80, next 0, 80, 60, 60. Next, to find mean deviation about mean, we need sigma fi into mod xi minus x bar. That is sum of the values of this column. Adding this values, we will get 400. So simple. We have n and sigma fi into mod xi minus x bar. So mean deviation about mean is equal to 400 divided by 40. That is equal to 10. So mean deviation about mean for continuous frequency distribution, just simple. Here see xi into fi. This is a little big values. We have 280, 440, 630, like that. We have calculator, so no problem. But we have a different method or a shortcut method to find mean. Just to get small values here. Okay, we can see that a shortcut method to find mean for continuous frequency distribution. Okay. We know mean and median are nothing but measure of central tendency. That is, they measure where the data points are centered. That is nothing but almost a middle value of the given data. So here we are assuming the mean as the middle value. So we can take assumed mean to be the middle or just close to it in the data. Here see in this data, here it has 7 rows marks. So fourth row is the middle value. That is the class interval 40 to 50 came in the middle. So midpoint of this class interval, that is 45. We can assume this to be the mean. So I take assumed mean to be 45 here. Just to find the middle class and find the middle value of that class. This is the assumed mean. Next, we can find deviation from this assumed mean. That is xi minus a. So if this xi minus a has some common factor that we can see, then divide it by that common factor to just simplify this value. So take xi minus a by h, where h is the common factor of this deviation. Common factor for xi minus a. We have x1 minus a, x2 minus a, like that, xn minus a. So take the common factor and divide it by that common factor. This we can call step deviation, di, denoted by di. So this is step deviation. So what is xi from this? We will get xi is equal to a plus di into h. We know the formula for mean. X bar is equal to 1 by n into sigma xi into fi. I from 1 to n. Substitute xi, a plus di into h. So just to substitute this value, we will get 1 by n into sigma a plus di into h into fi. Instead of xi, substitute a plus di into h. Then expand. We will get, this is 1 by n into, expand this value, sigma a plus di h into fi. A fi plus di h into fi. We can write sigma a fi plus sigma h into di into fi. H constant we can take outside, h into sigma fi into di or di into fi. Here common bracket, which is equal to, here what is sigma a into fi, that is a into sigma fi. Sigma fi is nothing but capital N. So this will become a into capital N by N, that is 1. So a plus, next remaining is 1 by N into sigma fi into di into h. You need not this values, just a formula for this x bar, that is a plus 1 by n into sigma fi into di into h. So we can write the formula for mean, x bar is equal to a plus sigma fi into di, I from 1 to n, divided by capital N into h. This is the new formula for x bar and shortcut method. This will give you simple values for calculation. Here di is nothing but xi minus a by h. A is the assumed mean, that is almost middle value, and h is the common factor in xi minus a. We can see this example by this method, okay? Then you will be more clear. Here we find xi into fi for finding mean x bar. So instead of this, we can find these values, that is di and fi into di. So we can make that two columns here. So here instead of xi into fi, we made two columns. Di is equal to xi minus a by h. We know a is the middle value. Here I have already told a is equal to 45. Now we can find xi minus a. Next we need the common factor h, highest common factor. See here 15 minus 45, that is minus 30. Like that 25 minus 45 minus 20, 35 minus 45 minus 10, like that. So 10 will be the highest common factor here. So take h is equal to 10. If you need, you can make another column xi minus a. Then you can find h easily. So next we can find di, xi minus a by h, that is 15 minus 45 by 10, that is minus 3. 25 minus 45 minus 20 by 10, that is minus 2. Here the value is small values. Next 35 minus 45 by 10, that is minus 10 by 10, that is minus 1. 45 minus 45, 0. 55 minus 45, that is 10 by 10, that is 1. 65 minus 45, that is 20 by 10, that is 2. 75 minus 45, 30 divided by 10, that is 3. Next di into fi, that is this column into this column. 2 into minus 3, minus 6. Here minus 6. Here minus 8, 0, 8, 6, 6. Now we want sigma di fi. Sum of these values. So it will be 6 minus 6, 0. 6 minus 6 again 0. 8 minus 8, 0. So this value is 0. So sigma di fi we have get 0. So what will be x bar? X bar is equal to a plus, a is 45 here. Sigma fi di is 0. 0 by n is again 0. 0 into h again 0. So 45 plus 0, which is equal to 45. So this is the mean. While explaining, you may feel like it difficult, but it is simple. Values are simple. You can use any method. So you can find x bar by this method in this case. Then mean deviation about mean is nothing but 1 by n into sigma fi into mod xi minus x bar. X bar we have get 45. Next substitute this values, just like we have done before. We can see more examples later. So today we have seen how to find mean deviation about mean for continuous frequency distribution, and also one shortcut method to find mean for continuous frequency distribution. Using that mean, we can next proceed to mean deviation about mean. If you have any doubt, you can ask in the comment. I will clear it. So this is all for today. In the next video, we can see mean deviation about median for continuous frequency distribution. Please like, share, comment, save and subscribe to our channel. Thank you for watching. Thank you.